вопросы.
Нет, к вам нет вопросов. Ну вот надо разобраться с тем, кто ведет занятия и конечно, группу. Полина Андреевна, может, вы напишите? И вам и не очень удобно это писать. Вот вы как...
Я могу на Гребенюку написать, в принципе.
Надо написать сейчас. Но ему ли надо писать? Они...
Ну, по поводу курсов ДЛ я ему писала, но во всяком случае можно задать вопрос.
Да, надо, наверное, задать этот вопрос. Надо. Напишите пока, а мы попробуем начать лекцию. Она будет...
Всем удачи, до свидания.
Спасибо, спасибо, счастливо.
До свидания.
До свидания.
Всего доброго.
Так, коллеги, вот сейчас, прежде чем перейти на английский язык, я попробую расширить экран, а вы подтвердите, что вы видите... Что вы видите сейчас?
Ну, видно все. Там количество часов на лекции практики.
Слайды. Well, dear students, let's start our English part of our lectures. Let's try to understand each other. Let's try to maybe communicate with each other. My English level is not so high, but I hope that I will be understood by you. And let's try. Our learning course is entitled Theory of Probabilities, Probabilistic Processes, and Mathematical Statistics. In fact, this is a 3 different parts of large mathematical area. These parts are connected with each other. These parts are based on the common ground, the common base. And maybe theory of probabilities is the first part, the first area, and the mathematical statistics is based on the theory of probabilities, and the probabilistic processes may be considered as some extension of theory of probabilities and mathematical statistics. But this is a formal title of our learning course. And we have lectures, 36 hours practice and exam. And your lecturer and assistant professor were introduced. In the base of our learning course, there is a very interesting and very modern textbook which prepared by very famous specialist in the area, David Forsyth. This is a famous American specialist, and this book is not first his textbook on the area. I'm very glad that I found the book, and that we will have an opportunity to share the book between among our students, and consider the book as the main textbook for our learning course. Now I will try to make a brief overview of the book. We try to follow the structure of the book, and we will learn not all the material, not all the parts of the book, not all the maybe topics, but main, most interesting and most important topics will be considered by us during in the framework of our learning course. But maybe I told you that maybe you will have this material as a book, as information for your further education and in this area, outside of our learning course, outside of a formal exam. But I think that it is very useful for future specialists in computer science. And we start to consider the first part of the learning course as a part which make a review of data sets and some characteristics of data sets as a focus area of data science, focus area of computer science specialists. Very large number of the problems are started from the data, from analysis of data set, from understanding which kind of data we have, which characteristics of the data and data set we have an opportunity to evaluate, to analyze, to understand, and to take into account during formulating of the problem and solving it. And this first part of the book and this part of our learning course is oriented to considering data sets, to considering some features of data sets and different possibilities to represent the data, maybe graphically, and to count some numerical characteristics without using any special tools of theory of probability, mathematical statistics, and so on. The first part does not use these special probabilistic tools. This is something like introduction to further activity with probabilistic tools oriented to the data. This is a point of methodical approach. This is a point of view to educational process of learning, process of for students for theory of probabilities and mathematical statistics. The next part of the book is devoted to main topics of theory of probability. And here you can see the main topics, which is unknown for you for today, but this is for information. And the third part of the book and our learning course, which is entitled Inference. In fact, this part corresponds to mathematical statistics. and maybe you see you can see the topics, sample populations, confidence intervals, very important statistical problem, statistical significance, and different tests, Chi quadrat, F, and T, and some other very important statistical topics of mathematical statistics. Then the fourth part, I think that fourth part will be outside of our learning course. Maybe we have a time and opportunity to consider something from these tools. But this is a very important, very popular topics for machine learning and data science. And you will have a possibility, an opportunity now to make a glance into these topics, these areas, and you will have a base, probabilistic and the data science base for future learning of special learning course here in our university and outside of university when you will enter some educational programs of IT companies. Maybe you know about this system. And this is a final part of the content of the book. You will have an opportunity to see and the clusterization and regression and just a moment, and classification based on different approaches. And maybe you know, I hope you know about Thomas Bayes, which he was a very famous, he is very famous person in theory of probabilities and in data science, and many important approaches in the modern data science are based on his theorem, Bayes theorem. We'll consider the theorem in our learning course. This is a short introduction to our to content of the book and to our activity during lectures. And now I will try to change slides and to start the first topic of our learning course. Short break. Do you have questions? Do you understand me? Please, your comments, if any.
Yes, I understand you.
Thank you. Thank you. Thank you. Well, let's continue. And if you have question or comment or something else, please break me, and I will try to answer your questions and maybe comments. Well, let's continue. The American approach in education, in mathematics, in computer science, is based on practice, is based on very large number of different examples, and this book is follows this approach, and I will try to follow as well. I prepared and I will continue slides for each lecture, and these slides mainly are prepared by copy-paste from this Forsyth book. I propose you to hear me, to read these slides during a lecture, and maybe to extend your knowledge, to support your knowledge by reading the book. I try to write in the slides the main but brief formulations of definitions, of explanations, of pictures, and other comments. But detailed information, detailed explanation is represented in the textbook. Well, this is a comment. And first topic and first part describing data sets corresponds to the first chapter of the book. And first topic in this first part is entitled First Tools for Looking at Data. We discuss here how to start our understanding, our learning, our maybe detailed impression about the data which should be prepared by us. The first question, and based on the mind of David Forsyth, the most important question for a working scientist: what's going on here? This is a so general question, the question which is oriented to understanding of the situation of the different circumstances, environment, and so on. But to understand what's going on here, we maybe should have pictures of data sets, and it is very important and it is very useful for understanding. We should have some ideas about analysis and making conclusions about the data inside the data set. And we should maybe understand which structure of data and the structure of data set should be considered or constructed. And based on the mind of David Forsyth, this is an activity which is known as descriptive statistics. Descriptive. It is part of mathematical statistics, but now we will, during this introduction, we will not use or we will not introduce special probabilistic and statistical terms. We will introduce some terms from data set theory, from area of maybe more wide area of knowledge which deals with data. But we will not consider data in general. We will consider some special representations and some structures of data, and then introduce some probabilistic and statistical concepts which are oriented to these data, kinds of data. Let's introduce some terms. What does it mean, a data set? Data set is a collection of descriptions of different instances of the same phenomenon. It is very important. Different instances, but the instances are oriented to the same object or same area or phenomenon. These descriptions could take a variety of forms, but it is important that they are descriptions of the same thing. And some examples. The examples in this book are not random, are not occasional. The examples are very interesting, and all of them correspond to the topic, to the area, to the data science in this situation. Let's consider a daily rainfall in the garden for many years. These are specific data concerning rainfall. A height of each person in the room, or not in the room, but in the company, in the district, region, and so on. This is so practical. The number of children in each family on a block. I don't understand what does it mean, a block. Family in the city, in the region, in the country. And this is a sociological term, and it is practical and important. And as an example, whether 10 classmates, not only 10, whether classmates would prefer to be rich or famous. Maybe you have a similar problem for you, for yourself, for you personally. Which objective is most important for you? To be rich, to be famous, to be maybe something else. And similar data may form a data set and may be analyzed from different points of view. We consider some terms, we introduce some terms concerning these characteristics of data sets. The descriptions in the data set can take a variety of forms. I maybe confirm that there are some different approaches or kinds of representing data. It depends on physical nature of data, and it depends on the problems which should be formulated on the data. And sometimes it is better to use numerical data or graphical or images or sound or I don't know what. And all the kinds, all the types of this data are useful and are applicable in for different problems. For example, this example will be continued. For example, we might record whether each of 100 classmates or passers-by prefer to be rich or famous. And these are so-called categorical data. What does it mean, categorical? Let's read the formulation. A description could be categorical, meaning that each data item can take a small set of prescribed values. For example, values rich or famous, or male, female, or maybe since you are second year students, then 2 is a categorical data item for characterization of your year. A year ago you was a first year student, next year you will be a third year student. Only 5, no, maybe 6 integers are characterized your educational level or year in the university. This is example of categorical data as well, numerical but categorical. Categorical, because let's again read again. Each data item can take small set of prescribed values. Or your, for example, your grades, your mark on the learning course, on exam. In the school, you had 12 level marks, and these are categorical data. Now you have 100 points, but you have not other points than these 100, not 60 and a half or something else. And this information, this feature characterizes the data as categorical. Categorical data could be ordinal, meaning that we can tell whether one data item is larger than another. It is non-applicable for all the categorical data. For example, for male and female, we cannot say that male is better, larger or better than female or not. Or, for example, your profession, teacher, physician, worker, and so on. These are typical examples of categorical data. We have not an opportunity to order, we have not an opportunity to realize some arithmetical operation, mathematical operations on this data, and so on. But sometimes we have an opportunity to order the categorical data and can tell whether one data item is larger than another. For example, the data set with the number of children in the family. Categorical, because it uses only non-negative integers, but it is also ordinal, because we can tell whether one family is larger than another. 3 children is larger than 2 children, and so on. The next type or class of the data, categorical, some ordinal categorical data appears not to be numerical, but can be assigned as a number. This example with rate the usability of an interface of maybe some information system. The range is proposed from very bad to very good, and 5 levels: very bad, neutral, good, and very good. And some numerical grades are introduced. This is a special approach of forming correspondence between numerical characteristics and non-numerical. But this is not the same than numerical information, than results of measurement of something. For example, what is the distance between bad and very bad? If we subtract -2 from -1, we obtain a 1. But what about the distance between very good and good? 1 as well. But is this the same? The distance between very good and good? Is it the same as the distance between bad and very bad? We don't know. This is incorrect to say about the distances between these data items. So, as a result, we should consider these numerical data as categorical, and with understanding that the worst is -2 and very bad, and then the bad is a better, neutral is better as well, and so on. The best is very good, and the worst is very bad with -2. Another class of data, another type of data is characterized as continuous variables or continuous characteristics. All physical characteristics of all the objects are continuous. If we have an opportunity to measure weight, height, temperature, light, distances, linear distances, and so on, all these characteristics are physical, and the continuous values correspond to these data items. What is the difference between continuous and categorical variables? We have an opportunity to analyze numerical continuous values based on mathematical tools, non-mathematical tools. We can define mathematical operations, and we can add, subtract, multiply. We have an opportunity to calculate some numerical characteristics which explains the nature, the processes with this data, and maybe we can tell that we can say that from continuous data we have an opportunity to extract more information during the analysis. But sometimes we have no continuous data, sometimes we have only limited data set with different characteristics, and sometimes we have data set with instances, and which are characterized from different points of view. For example, weight, height, temperature, from this example. And part of items, for part of items, not all the characteristics are known. Some characteristics are passed. We don't know, for example, temperature of first instance and height of second, and so on. But we have a data set, and we need, we have to use it for formulating and solving the problem. And the very important step in data science in this situation is so-called preprocessing of data. And as a result of preprocessing, we have to have full data set with all necessary numerical or categorical characteristics without passing, without maybe without instances with a missing characteristics. It is important part, but maybe this is outside of our learning course. It is very important, but outside. The examples: the heights of all people in the particular room, or maybe not room, and the rainfall at a particular place for each day of a year is a typical continuous characteristics. For analysis data set, for working with data set, we should have some formal tools. And we introduce some tools and concepts for description and operating with a data set. And first of them is a concept of a d-tuple. Tuple. What does it mean, a tuple? In fact, this is a list of elements. But this is specific list of elements. Let's consider an array in, for example, in a Python or in a other programming language. Array with in different elements, not numbers or not only numbers, maybe not array. My example maybe not so good. The elements of tuples may be represented by different types of data. And for example, a person which is characterized by age, by male, female, sex, by post address, by number of his phone, and number of and sum of money in his bank account. These data are so different. The types of data are so different: categorical, numerical, and so on, continuous. But the data are collected and ordered. And first position is name, and the second position is a sex, and third position is a post address, and so on. This is a typical example of a d-tuple. And the explanation here on the slide. Each element has its own type. Some elements might be categorical. And we say about number of elements in d-tuple, d elements in d-tuple, and considering a data set, we will write n as a size of a set with tuple, number of tuples in the data set. D, and D is a number of elements in a tuple, and n is a number of d-tuples in the data set. An example of data set with the tuples: 11 characteristics for children maybe in the school, and the number of children is represented here and characterized by n. We should compare the concept of a d-tuple with concept of a vector. You know from school, and not only school mathematics, what does it mean, a vector? It is similar concept, a similar object with a d-tuple, but not the same, because vector is an element of vector space, and all the components of a vector have the same nature. Only integers, only reals, only functions, only I don't know what, matrices. But having a set of vectors, we have an opportunity to operate with them, to introduce mathematical operations and implement the operations with the vectors. For example, adding, multiplication, subtraction, and so on. This is a main difference between vectors and d-tuples. When we deal with data sets, mostly we use d-tuples with different kinds of data, with absence of possibility, with no possibility to calculate something like in mathematical vectors.
Sorry. Can be a tuple part of a vector?
Can be a tuple, can be considered a tuple as a part of a vector?
Yes.
Maybe no. Vector may be a part of a d-tuple. As a vector may be considered as a subset of as a part of d-tuple. For example, the element of tuple is something two-dimensional. For example, sizes of a rectangle. I think so, but not the tuple is an element or part of vector. Based on previous explanation about operations with vectors and different formal limitations. Well, thank you for your questions. Please ask questions if any. Well, let's continue. We will use a special designation for data set with these figure brackets, and sometimes we will refer to one item inside the data set. We will use xi, but sometimes we will consider a part of data set, a subset of data set x, and we write special designation xi in brackets, in figure brackets. These are some designations. Let's continue. We will consider some examples which will be analyzed from different points of view during this first part describing data sets. Here we have two examples of data sets in table 1. The first one, 10 people, and very interesting and very special characteristics, net worth. These are people which you may meet in a bar, maybe you or maybe author of the book. What does it mean, net worth? This is a value of all the property of a person or company after taking away what the person or company owes. In fact, this is a sum of money which have a person. Maybe this is a simple explanation. A sum of money which have a person. This is income, maybe, after payment of taxes, maybe. But it is not extremely important for us here. We consider a data set, 10 persons, which are occasionally visited a bar, and their personal financial level. On the right table, we have 20 items, 20 instances, and the characteristics of, not 20 people, 20 different cheeses, and some test score for each kind of cheese. We will analyze these two data sets during this part of during today's and the next lecture. Another example, another kind of data in the table 2 is a categorical data. And we have two different gender characteristics, boy and girl, and on the right column we have the goal of a boy or a girl to be good in sports, or to be popular, or to have good grades. Three different types of objectives of these ladies and gentlemen. We have another kind of data here. And now we will try to discuss how to represent the data from the table using different, not very special, but using different tools. Since we have only 10 or only 20 items, it is not very hard to make a glance on the table in general, to consider, to make some conclusions about the elements of these data sets. But if we have a large data set, if we have a data set with different characteristics, and we, for example, need to compare some elements of data set to order maybe, or to choose the best instance or worst, or subset of best or worst, and so on. It is so hard to make a similar conclusion having only the table. And the different graphical and different numerical characteristics can support us in our analysis, in our understanding of the data. We will start from very simple tools, which is entitled a bar chart. A bar chart is a set of bars, one per category, where the height of each bar is proportional to a number of items in that category. Let's consider the first one. We had boys and girls, and as I understand, in this data set, 250 girls and maybe 230 boys. Here we have numerical scale, but here we have not numerical scale. We have only categories, positions, boy, girl, or categories from the right column, sports, grades, and popular status. And here we have the same characteristics of each category. Only 100, about 100 would like to be good in sports, 25, 250 would like to have a good grades, and 150 to be popular. This is a so simple and good tools for representing categorical data. Very similar, but another characteristics is in type histograms. Histograms. We have scales in all the axes, vertical and horizontal. And here, well, the histogram is a generalization of a bar chart. We divide the range of the data into intervals from 0 to 1.25. We divide this interval into sub-intervals, and length of interval characterizes the data numerically. But length of interval here does not characterize a subset of boys and girls. And in fact, we had an opportunity to represent these bars wider or in this X or more short, and the sense will be the same. But here we have scale, numbers, and numerical representing. These two histograms correspond to our table 1 with net worth and test scores of cheeses. Here we have an opportunity to analyze something. For example, the first category of persons with a minimal net, with minimal value is between 0.95 and 1, and these are 4 people, and no people in this interval, and so on. We have an opportunity to analyze the data set based on a histogram. Histogram is a very important and interesting characteristics, and there are different kinds of histograms. We make a glance to some of them. For example, histogram can plot only part of data set, and this type of histogram is called conditional histogram or class conditional. For example, here the histogram of a data set with people and body temperatures as a characteristics. Here. And here you have 2 conditional histograms for male and female. The author of the book, David Forsythe, said that he don't know which histogram for male and for female, who has higher temperature and who is more cold. We don't know, but these are examples of 2 conditional histograms. Based on histograms and bar charts, we have an opportunity to make some conclusions. Which one? For example, the most of data set, most items have a temperature near near 98. This is in Fahrenheit degrees, not in centigrade. Sometimes for one gender, for male or female, the most persons have more high temperature in Fahrenheit. Here we have some changing, increasing and decreasing of the temperature depending on the value of temperature. I don't know which analysis we have to, which conclusions we can to construct, but histogram is the base for these conclusions. Histogram contains the necessary information. But to make analysis more detailed, more deep, we can add some numerical characteristics of the data if we have an opportunity to calculate these numerical characteristics. And we consider some very important, very distributed characteristics, starting from one-dimensional data or scalar data. Here we will consider only numerical data and continuous data which are represented by real numbers. Why real numbers? Because if we divide integer by integer, we receive in the result non-integer value. And here we deal with real numbers. And these numbers can be added, subtracted, multiplied by constants, and maybe we define other operations, and all the data may be allow these different operations. The first characteristics, the mean. Very simple, very important, and very applicable in different data sets, problems and analysis. What is the definition? Not the explanation. Simple and effective, sometimes known, this characteristic sometimes known as the average, mean and average. But mean is a term, average may be considered as a characteristics. The mean characterizes the average value of an item. And the definition: assume we have a data set X of n data items, and the mean is a result of such calculation. Do you understand this operation?
Yes.
Yes,
Of course.
I hope that you understand. This is the sum of elements of n elements xi, which is divided by n, by number of elements in data set. Maybe you know the joke about the average temperature in the hospital. Do you know? This is a joke because average temperature in the hospital is good, but it is not characteristics of individuals, because somebody has a very high temperature and very ill, very sick. Somebody has a very low temperature, he has died, and so on. But in general, in the average, the temperature is normal. This is a maybe negative example or negative characteristics of the mean, but in many other situations, mean is a good numerical characteristics of data set. Let's consider an example. Example with our persons which characterizes by income. A group of 10 people who talk about the money. Their average people and their net worth is given in table 1, and the mean is $107.9 dollars of $1,000, I don't know. Let's remind this example. We calculated mean of this data set with 10 people. It is understandable because the minimal characteristics is 96, and here we have 120, 24, and the average value is 107, and it is correct. Some properties of the mean. It is very important, maybe not very hard to understand, but I have not graphical representing here, I have not picture. I hope that you will consider these properties in details in practice or in your experimental part of your work. But three main properties. If the title of this property here is a scaling data. We multiply each item in the data set by a constant. And this is the same, then calculate the mean without multiplication and multiply the mean by the same constant. The result will be the same. This is a scaling, in fact. The second property, translating. Let's translating the data. Let's consider the situation. Each item is moved by a constant, for example, on the right or on the left from the original point. Let's add, for example, to your age 10 years. For example, 10 years to each person in your group. And let's consider mean of your age after adding 10 years to each person, or consider your mean or average age and add 10 years to the mean. The result will be the same. This is translation of data on the right or on the left. And one more property. What does it mean, sign differences? If we take into account the sign plus or minus. And the sum of signed differences from the mean is zero. When we consider differences between each element of the data set and mean, we will obtain some positive and some negative results. The sum of these results is equal to 0. These are main properties of the mean, and we will consider similar properties of other characteristics of data sets now and in future, and it is normal for theory of probabilities and mathematical statistics. Based on these properties, we have an opportunity to analyze something using these characteristics, for example, the mean. The next characteristic is standard deviation. Standard deviation. let's read the introduction. We would also like to know the extent to which data items are close to the mean, which distribution of the 1D of the scalar characteristics on the straight line, on the numerical straight line around the mean. Are they close to the mean or are they far from the mean? The mean does not characterize this distribution. And to understand how close the elements to the mean, we should calculate another characteristics. And this information is given by the standard deviation, which is introduced with the mathematical expression. We consider the same data set X with n elements, and standard deviation is the sum of squares of differences between an element and the mean. On the previous slide, we had an example, very similar but not the same. The elements in this sum have a different signs, plus or minus. Here we have squares, and all the components are positive or non-negative. So we have sum of squares of distances between element and the mean, and this sum of squares is under square root. This is a very distributed, very applicable characteristics of distribution of data on the numerical straight line. How to understand, how to think about the standard deviation? The recommendation, you should think of the standard deviation as a scale. It measures the size of the average deviation from the mean for a data set, or how wide the spread of data is. And for this reason, this standard deviation is considered as a scale parameter. And having the mean and standard deviation, we have more information about the data set from this point of view. The standard deviation has specific properties. The properties differ from properties of the mean because the nature of these two parameters is not the same. If we translate the data, the standard deviation does not change. The deviation is not changed. Only translation is introduced by this constant, and distances between the mean and different items does not change. So the first property is true. Scaling data implies to the characteristics, and we have the similar property. We have an opportunity either scale the data or or introduce the multiplication of this constant to the standard deviation. And the proof or explanation follows from this mathematical formula. It is not so hard. I should say that the book contains not only formulations of these properties, but some proofs of them. And if you want, you have an opportunity to read and to learn these proofs of the theorems. Well, the next property. For any data set, there can be only a few items that are mainly, that are many standard deviation away from the mean. So from which the items which distance from the item to the mean is more than standard deviation, many standard deviations. For n data items xi whose standard deviation is sigma, this is a Greek letter sigma, typical designation of standard deviation in theory of probabilities and mathematical statistics. We have data set with n items and standard deviation sigma, and there are at most this number of data points, line k or more standard deviation away from the mean. There are at most this number of data points, line k or more standard deviations away from the mean. I think I'm not sure that this is a mistake. Let's check. I will check in the book and you will check as well. Maybe n here and divide by k squared, but I will check. And next property. For any data set, there must be at least one data item that is at least one standard deviation away from the mean. At least one or more than one data item for which distance from the item to the mean is more than one standard deviation. Because the standard deviation is an average characteristics. We divide by n. And having the average characteristics, we should support this average by a large distance, at least for one element from the mean. Some explanations, maybe detailed explanations to these properties you can find in the...
Excuse me, I have a question.
Yes?
What is the difference between a data item and a data point in the third point?
Not difference. Maybe here we deal with 1D items, one-dimensional or scalar data. And we say here only about weight or only about sum of money, and the one-dimensional data are in our focus here. Well, students, as I understand, the time is over, and I will break my lecture for today. The first lecture was maybe so hard for you and for me, but I hope I'm optimistic in my viewing of future. I finish for today. Do you have some questions about
Я пока еще время осталось, я быстро на русском, чтобы не формулировать. У меня к вам вопрос по поводу standard deviation. Там разве в формуле не должно быть в знаменателе n-1? Так, данный вопрос. Посмотрите, вот тут формула.
Ну, давайте так, если вы очень быстро хотите. Мы дойдем в математической статистике для исправленной дисперсии, и вот там начнется n и n-1.
Да, все.
Мы с вами поговорим, почему. Это самое простое, что вводится. Есть право на существование одного и второго.
Все, понял, хорошо, спасибо.
Так, а вот тут Полина Эдуардовна написала, я не имел возможности этого прочитать, вот пока у нас была лекция, послушайте, может быть, это важно для всех. Все группы в июле были подписаны по составу на весенний семестр. Сейчас мы работаем над тем, чтобы перенести списки групп из базы данных ЦИСТ в нашу базу данных. Есть небольшие технические проблемы, которые надеемся устранить в ближайшее время. Это написал Вячеслав Гребенюк, который руководит вот этим вот центром дистанционного обучения. То есть список группы взят неактуальный. Но над этим работают. Поэтому у меня просьба ко всем, пожалуйста, к следующей лекции, поделитесь вы ссылкой этой, поделитесь книжкой. Вот такой вопрос к вам. Будете читать эту презентацию, выкладывать ее в общий...
Да, выкладывайте, конечно.
Хорошо, но я буду выкладывать по лекции. У меня презентация длинная, я выложу только то, что я прочитал.
Хорошо.
Это будет называться лекция 1. Ну, вот сегодня чуть-чуть дальше я подготовлюсь и выложу. Тоже делитесь ссылкой на Google Drive, чтобы все могли увидеть. Так, еще вопросы? Нет вопросов, да? Всем спасибо, лекция окончена.
Всего доброго.
До свидания.
До свидания.
До свидания.
До свидания.